Alright, we are back with another installment of this wrangle series. We're going to keep going on with these wrangles so you can fully understand how they work. We're going to look at something fairly simple. I mentioned in the last video how I was going to show you how to do something cool with these little star lines that we made. I'll show you how to make them grow on, procedurally of course, so they will not all do it at the same time. If you did not watch the last lecture, you should do that right now. There'll be a link below in this video. This video that you're currently watching is completely based off what we did in the last one, so if you did not watch it, you should, or else you will have no idea what we're talking about here. You also won't have this scene file unless you downloaded it from the last video. There's a link there as well to show you where to get it. I recommend that you always download the included HIP files. As you might already notice, there's information in here that you didn't see on the screen of the last recording. And if you dive in, you'll see there's all these color-coded boxes. This information goes with this node, this information with this node. There's a lot of extra information that you get when you download the file. Even sometimes in the wrangles, there will be commented lines of code that tell you a little more information. So it's always a good idea to download every file that I offer. So let's get into this. Open up your own version that you made, or open up the file that you downloaded off of my Ko-Fi site. And we'll start adjusting what we did from the last video to make these things grow on in a cool procedural nature. And of course, we're going to start on the easy side. This is the flat plane, the flat grid side. We always want to make it easier for ourselves when we're prototyping something. So just dive in and let's zoom into the bottom of our chain here. And we're going to have to add a couple nodes here, but not much actually to make this work. So the first thing we are going to do is drop an add node. You should be familiar with this from the last video. And we're just going to go over to our polygons tab and say remove the unused points. We want to get rid of all those points that we do not need. Now we're going to drop something called the connectivity node. Wire it in. You may or may not be familiar with this. If you aren't, I recommend watching my Master Houdini Effects course that's still available over on Udemy. It gives you a general overall view of how to use Houdini. Every of the major areas of Houdini are covered, starting at the very beginning basics. You should check it out. Use the link below that's in this video if you do go over there to purchase it. As an instructor, we get a much larger percentage when somebody uses our instructor link to make the purchase. So, if you do not know what the connectivity node is, it's very simple. We're going to keep it in point mode, and it creates an attribute named class. All it's going to do basically is give us a way to have a unique ID for each one of these little star splotches or whatever you want to call it. So right now, there's no way of differentiating one of these poly lines that's here or here or here. It's just all poly lines. There's no way of knowing, hey, this is this one unique object and this is another unique object. So a very simple way of doing that is with a connectivity node. Now you can of course go to your geometry spreadsheet and you'll see class, and right now it looks like a bunch of random numbers, but if you sort it, you'll see a bunch of zeros and a lot of zeros, and then you have to go farther and farther down. Eventually you'll see 1, 2, 3, it's going to keep going. And basically this is telling you we have 13 things that have been identified as unique. Okay, 13 objects. Now we actually have a little more than 13 objects. But some of these ones that are very close together are probably picking up the same connectivity. It's just an artifact of how this was generated up here in our wrangle node. So let's dive in, and geometry spreadsheet is great, but it's not exactly easy to know which one is 13. Okay, how are you going to know? You'd have to look at a point number and find point 1179, enable your point count, and then look for it. Nobody wants to do that. So there's a much better visual way of being able to see the value of attributes. So if we go down here and look at this little thing here, it's called the visualization. If you right click it and click the plus and say marker, click on marker. Now you can give it any name you want. We're just going to do class, and the label also class. These have absolutely no bearing on what information it shows. What's important is down here, attribute. Put the attribute name in here, class. Now hit close, and now enable it. And if you right click, you can see now class has a little check mark. And now if we zoom in, you can see It's actually quite hard to see. These are small little numbers. You probably have no chance of seeing it on the actual video screen, but in your own session of Houdini, you should see it. That looks like a 3. This is an 8. And you can see that all of these, actually, these 3 here are a cluster. These all get 8. So as of right now, these will act as one unit. Let's say one object. Not a big deal. We can fix that later on, but in reality, it wouldn't even really matter. Think about when you're working on a show, you gotta pick and choose your battles, what you wanna spend your time on fixing, and it really wouldn't matter if a couple of these things got triggered to come on at the same time. If this was in a movie for an effect shot, you're gonna have a moving camera, you're gonna have lighting, there's gonna be things in shadow, things in bright areas, there's gonna be motion blur if things are moving and the camera's moving. So a lot of things you wouldn't even be able to tell if they were being triggered at the same time. You typically want to try to minimize it, but in certain situations it really doesn't matter. And like I said, you gotta just pick and choose what you want to spend your time on fixing, because time is extremely valuable when you're working in production. So you can look around some more and you can see this is what it calculated as our 0 geometry. But what we're gonna do, we're gonna use this connectivity node in the class attribute. This is gonna become our root, basically, or our seed value that's going to generate all of the random values that we're going to need to be able to then grow these things on in a very cool organic nature. And they're all going to be a little different and look randomized. So we can disable this since we don't care about seeing that anymore. And let's drop down a resample. And now let's disable maximum segment length. And we'll turn on maximum segments and say 100. You can see now we get a ton of points here compared to before. We just had 1 at the source and 1 at the target. But we're going to want a lot of them because this is going to be our trick of how we grow these on and off. We're basically going to be creating our own version of a carve node. And if you don't know what a carve node is, I'll show you later on. All a carve node does is allow you to carve geometry, and that means grow it on and off. So we'll look at that later. Let's make sure we scroll down, turn on this curve view attribute. This is going to become very useful and critical for this to work, actually. We need this. This is going to give us a value that is 0 to 1 down the length of these primitives, these poly lines. Without the curve view, we cannot pull this trick off, so make sure that is enabled. Let's disable our points. We don't need to see all that little blue dots. And now, for the star of the show, like usual, drop down a wrangle, plug into the first input, and we're going to create something called start frame. And let's create it as an attribute. So let's hit I and the @ symbol and call it start frame equals. And now I'm going to write a long string of code here. It's not that long actually, but it is going to probably look very confusing at first. I'm going to write it out and then I'll explain it. We're going to do fit 01 and then rand and then use our class attribute here. And then we're going to say, let's do 10, 75. And let's click off here. You'll see it gives us the little error like usual. It's complaining about the integer casting, the float to int thing. So like usual, we can fix that. And now it goes away. You could create this just as a local variable. However, then you couldn't go up to your geometry spreadsheet and look at it. So you can see we have a random range here, 10. And it looks like 73 is where it ends. That's just the random number that it's generating, and as the name implies, that is going to be the start frame. So what does that mean? That is going to be the start time that these things start to grow on. And because each one of these has a unique class, barring a few, some of these ones that are very close do share the same class, so they will start at the same time. You could actually now, since we did create this as an attribute variable here, you could go here, hit the plus, do another marker. Again, these names don't matter. You could just do SF to indicate start frame, and then type start frame, hit close, enable, and now let's disable class, and now SF is the only one that's on. And if we zoom in, you can see in a very difficult way to see this though, unfortunately. It's not easy to see. That says 27. So this will start growing on after frame 27 hits. This will be 69, it looks like. And all of these will be 69 because they're sharing that same class attribute. And you can see the theme here. This is 50. So they all just get a random number to start on. Let's disable this. Of course, if you wanted to randomize the randomness, you could multiply this by anything you want. Now it's just changing our seed. So it's going to just change whatever random numbers were spit out. Now let's create a float. We want it float, and we'll call it carve val equals. And the reason we want this to be a float because we want to have a 0 to 1 value. Like I said before, the curve u value is a 0 to 1 value that runs down the entire length of each one of these poly lines. So you can think of that as a coordinate. And now we are going to create a 0 to 1 value that is driven by that start frame. And that is how we are going to be able to carve this thing and basically make it look like it's growing on. That might sound confusing, but it isn't. And it'll become more clear as you see the actual end result of this. So we can type smooth. We're going to use a new function here. And it asks for value 1, value 2, and float amount. So our value 1 will be our start frame. Our value 2, let's just use... Actually, we have to put the little @ symbol there. Now let's do @ start frame again. But add an offset, and let's just hard code something like 50 in here. And now we do @ frame. And of course nothing happens because all we're doing is initializing values, but carve val, you can now look up here at our geometry spreadsheet. Carve val is 0 on everything. Okay? And the reason is, let's back up for a brief moment here. Maybe you're unfamiliar with smooth. Let me type it in again down here so you can just see the help that pops up. Computes the ease in, out, interpolation between values. So all this is going to do is give you a value that is between 0 and 1, meaning it starts at 0, it'll end at 1, it'll give you every value in between. At some point, it'll be equal to 0.2, 0.37, 0.75, whatever. It'll go from 0 to 1 using our start frame and start frame plus 50. So let me try to explain that a little more here. If our random start frame happens to be 37 like this one is, then every frame going up to 37, this smooth operation will export a value of 0. Okay, once we hit our start frame, it'll then start slowly going up to a value of 1. Once we hit this value, 37 plus 50, so once we got to frame 87, our value would be 1, and we can watch that interactively here. Right here, carve val. You can see once we hit 37, it starts to go up and up and up. And then once we get to 87, you see now it's a value of 1. So just think about this value. It's basically going to be telling us where to remove those points along that length. And because our curve u goes from 0 to 1, we can use this value directly to help remove points. That still might sound confusing, but it is not, and I'll show you why, or how easy it is to use. Now we just say if curve u, let's spell it correctly, that does not work. Curve u is greater than our carve val. We don't need our curly braces, we're just going to do one line for now. We just say remove point and say 0 and pt num. Now look what happens. A lot of them disappear. Let's rewind. We'll hit play. Let's make sure we enable our little clock face here. And you can see what happens. We have much too much time on this timeline, but you can see they start to grow on, and they grow on randomly. They do all grow at the same speed or rate because we hard-coded 50 in. We can change that later, but like I've always Said in the past, start easy to just make stuff work, and then you can add bells and whistles. So this fully works and does what we want it to do. If this at all is confusing, let me try to explain it. We know that our curve U value goes from 0 to 1 down the length of this thing, and we have created a carve value that also animates from 0 to 1 based off of our start frame, the start frame plus 50, and the current frame. So all we're saying is if the point has a curve U value that is greater than the current carve value, remove the point. So at the very beginning, like say frame 10, that's the earliest any of these can actually even start to grow on, and some of them might not even have that random value. But at frame 10, our carve value is going to have a value of 0, which means curve U, every single point is going to have basically a value greater than 0 down the length. So if curve U is greater than carve val, which will be 0, remove the point. That's why they're all gone. They all are not there in the beginning. They've all been deleted. Now they slowly start looking like they're coming on because we're telling to delete less and less of them basically as this carve value increases over time. If that is confusing, maybe you should watch the values as you do this back and forth and see the visual example there, or the correlation of the number to what's happening. But that should be pretty straightforward. Now, let's make this more interesting. We'll just Alt and left drag it over. And like I said, we might want to offset this with something, because right now, even though some of them start at different times, they all take the exact same 50 frames to grow on. So you can do something very simple. Just copy this line here, paste it. Let's rename this to offset. Why not? Makes it nice and simple. Change this so that it's just a different seed. It doesn't really matter. And I mean, you could even leave this exactly as it is, but let's just modify it a little bit. 5 by 45. So now, every single group of these things is going to have their own unique offset that randomly goes from 5 to up to 45 instead of all of them having 50. So instead of adding 50, all we got to do is add offset. And now you'll see some of these things grow very quickly because some of them only take 5 frames to fully grow on. Some of them take a very long time. You can see like this guy here takes a while to fully grow on. That's because it might be getting the random value of 45. So you'd probably want to dial these in a little better. Let's say 3, and let's go crazy with like 145. And now hit play, and you'll see some of them are growing on pretty quick. Some of them take quite a while. Those are still growing very slowly. So that's how you can randomize it. And again, if you wanted to randomize the randomization, you could just change this, and now you'll see they automatically change. Every time you change this number, the pattern changes ever so slightly. So see, that's very simple and easy to do with just a couple lines of code. We're creating our own little custom growth system. Now let's copy this over again. But let's do something even more unique. It is cool that all these things grow on like this and they're all now fairly random, but you will notice, let's just isolate one of these. Every one of these lines actually still grows at the same rate within one of these star shapes, okay? They all grow on out at the same time. It would be cool if we could even randomize the speed at which each one of these is growing, and you can. I'll show you, let's do it with like a creative way here. Why not? Let's do a measure node. You maybe have never seen this before. Let's plug it in. Keep it to primitives and measure, let's say, perimeter length. And of course, we can go to our geometry spreadsheet. Now, you see nothing here named perimeter because this is on primitive element type. So we have to go over to our primitives tab, and you'll see now a perimeter, and you'll see all these random numbers that we get. Okay, and each one of our lines is its own primitive, so they each are getting basically a random value per line, which is fantastic, because again, we can use that as a seed. You could technically just use the perimeter value as is, But let's get it to our point level, because right now it's on the primitives. So we're going to do an attribute promote. Okay, drop that down, wire it in. Our original class was primitive. New class, we want to drop it down to point level, or just switch it to point level. Perimeter. You can keep it at average. Doesn't matter. It might change the value ever so slightly, but we don't care. All we want are some unique values on each one of these lines, and that's what it gives us. Now let's plug in, visualize it. Nothing changes, of course, because we haven't used it yet. Again, you can just copy this line, paste it. We can call this, let's just do rand mult, and change this to use the perimeter. And this we're going to want to change to something a lot smaller, like say 0.5 and maybe 1.5. And now let's do some parentheses here. We'll just do offset times rand mult. And click off of it. And now you should have seen something happen there. Now you'll see it looks a little funny. We got some popping happening there. So let's change this. Actually, we copied an offset that was an integer type. Let's change this to a float type. And you'll see it still looks like it's popping, and the reason is because we copied this line and we duplicated that integer typecasting. Now you can see it does what we want. So if you do speed things up by copying lines, just make sure you're not copying things that actually don't work for you or you don't need. That's one thing that can come back to bite you, but it's usually pretty simple to see. If you see pops and jumping like that, a lot of times it means it's an integer value when you're expecting a float. So if we back out now, you can see this looks much more unique. These things don't all grow on at the same time. They all start at different times. They even take different lengths of time to grow. And each line within an object actually has a unique growth rate. So it's pretty cool, pretty simple. It's not a whole lot of code, and this is all pretty basic stuff. It might look confusing when you start stringing together functions because you got this int, the fit01, and a rand. But it's really easy when you break it down step by step. So that's all I'm going to show you in this lecture here because it's getting a little long. I'm going to show you more with this though. We're going to have another lecture that works with this stuff, so make sure you stay tuned for that. And we're going to do even cooler stuff. And we're going to move this over to our spherical surface because it's always more fun to work on a three-dimensional shape and not just something on the ground, a flat grid. So stay tuned for that. As always, it's that time. I got to remind you, hit that like and subscribe. Have to make that algorithm happy. Don't forget to check out the HEP file over on the Ko-Fi site. The link will be in the description of this video. It's always free, but feel free to leave a little tip or donation if you choose. That will help me continue to offer these for free. With that being said, alright, we are done, and stay tuned for the follow-up video. We're going to continue on this, so I will see you in the next one.